Under this optical activity, in this video, I am continuing with the previous video. So, on the optical activity, I have called this as part 2. Okay. Now here, let me give some example and then explain to you. So, we have here, suppose say 2-chlorobutane. 2-chlorobutane. So in this case, suppose if we have a compound which is like this, I will show this like this. C. Okay, I'll better put it here. This side I'll take here as CH3. This side I will take it here as H. This side I will put it here as C2H5. I'll explain to you what is this meaning here. And over here I have Br. Let us say that this is Br. Sorry, I have written here 2-chloro, so I'll put it here chlorine. So 2-chlorobutane. So this is 2-chlorobutane. How it is 2-chlorobutane? Don't get confused. This is number 1. This is say 2. Okay, 2. I'm doing the numbering. This will be 3 and 4. Followed? How this will be 3 and 4? Because this will be what? CH2, CH3. CH2, CH3. So this is what? 1, 2, 3, 4. I hope you followed. Now here what I have shown is like this. Let me just explain to you in the same manner. Suppose say there's a carbon here. The one which is shown with the thick line, I will make this side thick, little bit thicker. Don't make it too thick. We can show this thick either. This is called as wedge structure. WEDG. So this is facing towards you. Okay, this is facing towards you. Remember this hydrogen. Don't make very thick, little thick. Now this chlorine and this methyl group, they are in the plane of the board, and this is away from you. So I'll show that like this. This is C2H5. This is C2H5. This one is carbon, so I'll call this as this side methyl. Okay, I think I'll put it here as H, so that this color is also red. I'll put so that you can follow what I'm explaining. Okay, this is chlorine. This side is H, and this is away from you, which is Cl. Okay, I'll put it this way. This is the chlorine. This is methyl. See, this is methyl. This is Cl, and this one will be away from you, which is away from the observer. So that become like this. Can you understand this now? So see this. I hope you can follow properly. This is the actual structure. Sorry. Here we have this. Okay. I hope you can see here clearly with the one carbon here in the center. This is the carbon. This chlorine and methyl, they are in the plane of the board. Okay. This is facing towards you, and this one is away from you. Okay. This carbon will be asymmetric carbon here. This is asymmetric carbon. I hope you understood. Okay. Now this carbon is asymmetric. Why? Because it has got the 4 different groups attached to it. Okay. Now this will be 2-chlorobutane. Now this 2-chlorobutane, if we just happen to keep one mirror in front of it, plain mirror. So now you'll understand in a better way. And this side I'll put the same its image. So this is the object, say. Then when you stand in front of a plain mirror, you will see the image inside. Same thing what I am trying to explain. So here, this will be chlorine. This will be chlorine, which is facing in front. Okay, and this side is methyl. On top of it, here there is methyl. This is H. This is here away. This is facing towards you, the one which I have shown the thick line. That one is facing towards you, so we'll put it that way only. This is facing towards you, and this is what here H, and this one will be like this, C2H5. So this I will call it as A, this is say B. Now see, A and B both are optically active, but this compound A is the object. This is the mirror image. If this one rotate the plane of plane polarized light to the right, this one will rotate to the what? Left. This is dextrorotatory, this will be levo, and vice versa. Now how you can define that optical activity again further? See, if you just happen to remove this and place it on this, imagine that I am lifting this up and I am trying to place on this. Then chlorine will come over what? H. This chlorine will come over H, and this H will come over chlorine. Alright, this CH3 and CH3 of course will be this side, see, like this. Okay. Then what you can observe here, see, this will be H. Correct, I think I made a mistake here. This should be C2H5, which will be away from you, so which I have to show this side. Okay, let us put this like this. Okay, now see, this object and this is mirror image. So object and the mirror image are said to be non-superimposable. Non-superimposable object and mirror image. Okay, or object is non-superimposable with its mirror image. We can also call it like this. Object is non-superimposable with mirror image. Now this is called as, these are two, A and B are called enantiomers. These are optical isomers. Remember, optical isomers. So optical isomers are what therefore? Enantiomers. The compound containing asymmetric carbon, and their mirror images are non-superimposable. Now again I explain. Suppose I just put it like this. This is said to be what? Superimposable. Okay, superimposable. If I keep it like this, non-superimposable. Now this carbon is called as also chiral. This is known as chirality. So chiral carbon. Alright? And non-chiral will be what? Suppose object and mirror image. If I just put it this way, I'll put here A and another A this side. Now these two object and mirror images here are superimposable. This is called non-superimposable. Non-superimposable. I think I'll rub, clean it, and so that you can follow properly. See, this is superimposable. Superimposable. So this is called as non-chiral. Non-chiral, or what is also called achiral. This is called chiral carbon, in this case carbon. Here there is no carbon. So just to get the idea, what is called as chiral and achiral. So it should be what therefore always chiral carbon. then only they will show optical activity. So what is optical activity? Compounds containing asymmetric carbon capable of rotating the plane of plane polarized light either to the right or to the left, okay, are said to be optically active compound. And the phenomena is known as optical activity. So 2-chlorobutene, if you just see, you can see it's two images here, A and B. So this number of, they are called isomers, optical isomers. Now number of isomers here possible are 2, and that is given by what is called as Fisher's formula. That is given by the 2 raised to what, n. N represents number of asymmetric carbon and number of asymmetric carbon. So in this case, asymmetric carbon is 1. Therefore, it is what? 2 raised to 1, which is equal to 2. And therefore, 2 optical isomers. 2 optical isomers. Okay, remember. Now, if there are, suppose, say 2 asymmetric carbon, then number of optical isomers will be what? 2 raised to 2, which will be 4. So, if 2 carbon are asymmetric, then optical isomers are 2 raised to 2, which is equal to 4. So this is given by Fisher, and that is called as Fisher's formula. Okay, so in my today's video, just understand this, what is called as chiral carbon, what is called as optical activity, what is called as enantiomers, and what is called as non-superimposable, and so on. That is what is called as distereoisomer. Distereoisomer is what, if there is one compound optically active, another compound also is optically active, but their mirror images are non-superimposable, then those are called distereoisomers, which I will explain to you all in my next video.